The first modern skyscraper was built in 1885, and since then, these monoliths of architecture have stood as marvels of our engineering capabilities. The Burj Khalifa, the world's tallest skyscraper, stretches 2,722 feet into the air and is built on top of one of the worst foundations in the world, sand. Its construction required 192 steel piles, each 164 feet long, and a foundation made from 110,000 tons of concrete. You might be asking how such tall buildings are prevented from falling over in high winds or tilting under the force of the floors above the foundation. To answer that, let's take a closer look at how skyscrapers are made. Today, skyscrapers are commonly defined as buildings that have more than 40 to 50 floors, though the world's first modern skyscraper, the Home Insurance Building in Chicago, Illinois, had only 10 stories. The definition of the skyscraper has shifted over the years as engineering capabilities have gotten better. Skyscrapers are one of the most efficient uses of space in a crowded city, but they present a plethora of engineering challenges. One of the biggest challenges modern skyscrapers face is the fight against one of Earth's most basic forces, gravity. As buildings get taller, the foundation and bottom floors have to hold more and more weight. That is why when it comes to skyscraper construction, one of the most important aspects is building a solid foundation. Many skyscrapers are built on bedrock, the layer of subsurface rock that is largely immune to shifting. In cases where bedrock is available to be built on, engineers will dig down to that level and anchor the foundation to the bedrock with steel or reinforced concrete columns. However, being able to construct a skyscraper on bedrock is something that is specific to geography and geology. In many places, bedrock isn't close to the surface. The Burj Khalifa, for example, had only very weak sandstone accessible to it due to the region's sandy nature. In this case, engineers had to use a series of long piles driven into the ground. This is another common skyscraper foundation technique, and it's based solely on the principle of friction. Rather than constructing the building on bedrock, the building sits on hundreds of piles that use friction forces from the sand to keep them from sliding down. This pile foundation doesn't technically rest on bedrock. Rather, it's just the friction between the sand and soil that keeps them from moving. After the foundation is built, usually using large amounts of concrete, then engineers can start building up. Advances in steel are largely what have allowed modern skyscrapers to come into existence. Skyscrapers are essentially built out as steel skeletons before all of the windows and exterior structure is added. There are beams and vertical columns connecting each floor, held together by rivets and bolts. Steel functions well in both compression and tension, whereas concrete really only works under compression loading. The ability of steel to be used in both tension and compression makes it perfect for engineering large spans in skyscrapers. All of the weight and force is transferred through the steel to the ground, where it's distributed through the concrete foundation. Once the steel skeleton and core is built, the rest is essentially just decoration. However, modern skyscrapers also have many things that work against them. These include wind and earthquakes. Skyscrapers' biggest daily threat is the wind forces causing them to wobble or crack. Engineers protect skyscrapers against the wind in two main ways. In many cases, the actual design of the building is altered to make it more aerodynamic. Back to the Burj Khalifa, this building was actually designed to minimize vibration wind loading, making the net wind force on the building essentially cancel out. However, not every skyscraper can be as geometrically interesting as the Burj Khalifa. Most modern skyscrapers will have something called a tuned mass damper. This is essentially a giant pendulum that sits near the top of the skyscraper and acts as a counterweight to absorb and cancel out the forces from the wind. And that's essentially how engineers do it. Through the advances in modern steel, concrete, and construction practices, humankind will likely continue to reach onward and upward through the construction of skyscrapers.